Okay, friends, we're going to come full circle with this last question and end the term with the first topic that we ever talked about, the fundamental counting principle. So what I want to do is I want to establish a pattern in how to calculate the next question, which is going to be, what is the chance? So, you know, Jenny will often say, like, just because the number changed every time doesn't mean it's not random. And she's right. She's right. Just like if you flip a coin over and over again, it can go heads, tails, heads, tails, heads, tails, back and forth, back and forth, back and forth. It just doesn't do that very often. It doesn't mean it can't happen, it just means it doesn't happen often, which is why we flagged her sequence number 1 as looking less random than sequence number 2. But that doesn't mean sequence number 1 isn't random, it just means it looks less random, which is an important statistical decision that you'll get into in later classes. But right now, I just want to calculate the chance that you can have the same number of runs as you have push-ups, if that makes sense. So just the simplest example is if you have one push-up. So if Jenny says do one push-up, and this is actually kind of a silly case, because if you have one push-up, then there's automatically going to be one run, right? I mean, it's silly. There's 3 possible push-ups you can do out of 3, which is 1. Or 100%. There's a 100% chance that that push-up is going to be its own run. It gets more interesting with 2. With 2 push-ups. Now with 2 push-ups, we actually have to use the fundamental counting principle. Because here's the deal. If we want to figure out the probability that both push-ups are different, essentially is what this means, right? It means whatever you do first, you can't do second. Let's first figure out how many ways we could actually do 3, 2, 1 push-ups in total. Well, the first push-up can be any of 3 ways. Either a 1, a 2, or a 3. The second push-up could also be any one of 3 ways. That's the total number of ways that you can do 2, 3, 2, 1 push-ups. 9. But if we want each one to change, let's figure that out up here. So there's still 3 ways to start. Jenny can call whatever number she wants first. That's going to be different because it's the first one. But the second one has to be different than the first one. So let's say the first one was a 1. That means the second one either has to be a 2 or a 3. Let's say the first one was a 2. That means the second one has to be a 1 or a 3. I think you'll see where this is going. You now have 2 choices for the second one. So the chance of having 2 unique push-ups in a sequence of 2 is going to be 6/9, or about 67%. This one's 100%. Now, you could also figure this out by saying there are 3 ways to repeat a push-up. 1, 1, 2, 2, or 3, 3. That takes away the other 3. Let's go to 3 push-ups. See if you can see a pattern here. Let's do the denominator again first. The denominator is going to be pretty straightforward here. The total number of ways to do 3 push-ups is going to be 3 choices for the first one, 3 choices for the second, and 3 choices for the third. That's 27. You could list them out if you wanted to. I don't want you to. I don't want you to list them out. But you could if you wanted to. There's not that many of them. Now let's think about the numerator. The numerator, the first push-up can be any of 3. The next push-up can't match the one before it, which means there's 2 choices. Now be careful. Don't fall into the factorial trick here. The third push-up simply can't match the one before it. It might match the one back here. So this is not 3, 2, 1. It's 3, 2, 2. Because, you know, she could go 1, 3, 1. That's still 3 runs, right? It's 3 different numbers. She can't go 1, 1, 3. Can't do that. But she could go 2, 3, 2. That would be 3 different numbers. So what do we got here? We got 4 times 3, that's 12 27s. Well, look what just happened. That just dropped below 50%. We have room for 4 push-ups? We don't. Let me clear the board and we'll do 4 push-ups to do one more example and then we'll go from there. Okay, so I put the cumulative results we've got so far in a little chart up here. So when you do 1 push-up, there's a 100% chance it's going to be unique. That's kind of silly. When you have 2 push-ups, there's a 67% chance that you're going to have a different one second than you did first. And when you have 3 push-ups, there's a 44% chance you're going to have a different one first, second, and third. What about 4 push-ups? What about 4 push-ups? Okay, so once again, I think it's easiest to do the denominator first. So, there's 3 ways to do the first push-up, 3 ways to do the second, 3 ways to do the third, and 3 ways to do the fourth. So that's going to be 81 ways altogether to do these push-ups. Please don't list them all out. 1 1 1 1, 1 1 1 2, 1 1 1 3. You don't want to do that. But you could, but it's more important to know there are 81 possible arrangements of 4 push-ups. Now, how many have a different push-up every time? Well, again, Jenny can start with 3 in the beginning. She can start up here with 3. The next one can't match the one before it. And the next one can't match the one before that. And the next one can't match the one before that. So hopefully you're seeing the pattern in the numerators. The pattern in the denominators you already knew from week 1 of this course. But the pattern in the numerators hopefully is becoming a little bit more obvious. Some of you may have even noticed that the 3's divide off and you're left with just 2/3, which is actually pretty cool too. But hopefully you're noticing that pattern. So you end up with, what's this going to be? 8 times 4 is 24 81sts, which is just 2/3 of that one. So that's probably going to be about 30%, I'm guessing. Somewhere in that neighborhood. So you see the chances going down. Every push-up we add, it becomes less and less likely that you're never going to have a push-up repeat itself in the next spot. Which is why I always gave Jenny crap. But just like she said, there is a chance that all 20 could be different in each spot. And what you're going to do in the last question is you're going to do math similar to this and show me what is the chance that Jenny is being random and we got 20 unique push-ups in the spot. So show me math like this and then give me what the percentage is equal to at the end. Go get it!